I had bought this 2006 Honda CR-V in May 2019 with a suspected head gasket failure and blown radiator. The engine will not run at all. I ran a cold compression test in my previous video, so now I will perform a cold leak down test to see if I can ascertain more about this engine and its problems. A leak down test in some ways is more useful than a compression test, as a leak down test measures the loss of air leaking from the cylinder and can often be traced easier. The first job to do is to establish that cylinder 1 is at top dead centre on the compression stroke. These are some of the tools needed: 19mm socket for wheels and crankshaft, 8mm socket, 10mm long reach socket, 16mm deep spark plug socket to fit a 10mm diameter thread spark plug, cylinder leak down tester and air compressor. Before we jack the vehicle up, it's best to disconnect the negative off the battery, as we're going to be working quite a bit on the engine. So for that, use a 10mm socket and just remove the negative and pop it to one side. Please observe the correct jacking place that Honda have pointed out with an arrow. It's like a strengthened plate and the head of the jack can go there. If you put the head of the jack on the sill itself, it can't take the weight of the vehicle and it will buckle up like it has done there. So with the trolley jack correctly located, we can just get the position correct, and then using a breaker bar and 19mm socket, just break all the nuts loose. We can then fully jack the car up and remove those nuts completely. The car is on skates in my garage due to lack of space, and it does enable me to push the car around. So then we can just remove the nuts and remove the road wheel, and then we have access to the crankshaft. Then we do need to make the car safe using an axle stand. Remove the two plastic clips marked yellow, one here and one here. It would seem most of the plastic clips are missing on the splash guard on my car, so it was easy to pull down, and there's the crankshaft pulley. Looking at the crankshaft, we can see 4 notches. There's a group of 3, the centre of which is 8 degrees before top dead centre, and the one above it is the top dead centre mark. That's the one we're interested in. So if you now look at the crankshaft pulley from the top of the engine, you should be able to see, it's very difficult to say, you should be able to see a mark cast into the timing chain case. Now you need to rotate the pulley with a 19mm socket until the top dead centre mark aligns. So here I rotate the pulley from under the wheel arch, and as you see, you'll see the first 3 indentations come up. There we are. So that's the first batch of 3, and then the last one is the top dead centre mark just there, which is where we need the engine. This means cylinders 1 and 4 are at top dead centre, but we need cylinder number 1 on the compression stroke, and the only way to find that out is to now remove the cylinder head cover. Now we have aligned cylinders 1 and 4 at top dead centre, we can remove the cylinder head cover so that we can inspect the alignment marks on the exhaust and intake camshaft sprockets, and also the position of the cam lobes. The cam lobes should be pointing away from the valves of cylinder number 1 if on the compression stroke. Let's get my little magnetic tray ready for the parts and remove the dipstick. Here's the 4 nuts in yellow. So now using a 10mm socket, we can remove the 4 nuts on the top of the plastic cover. And that one's got like a shoulder on it, and this one again has got a shoulder, and these 2 are just little cap nuts. Then we can remove the plastic cover, and there we can see the 4 coil packs on top of the spark plugs. So you need 10mm long reach for this. So the first one's a little bolt, like so. The second one is like a standoff that helps support the plastic cover. So this one's a little bit taller. There you go. Then a normal bolt, and then another standoff. So then we just need to remove the coil packs. They simply lift up gently and then push the plastic clip in and then pull the cable off. Push in and off, like so. And then just repeat that for the others. So up gently, push the clip in and push the connector off. When removing spark plugs, it's good practice to only undo them by one revolution, 360 degrees initially, and then blow compressed air down the tubes to clear the grit that would have possibly accumulated over time. Then remove them fully. This method should prevent any dirt or grit from dropping into the cylinders as the spark plugs are being removed. So now, using a 16mm spark plug socket, we need to undo all the spark plugs by 360 degrees. So that's just one turn first. And once we've undone them all by one turn, I'll then use compressed air just to blow out any grit that may have accumulated down the pipes. Now, when using compressed air, it's always wise to wear hearing protection and eye protection, especially when blowing compressed air down confined spaces. Just give it a little clean out like that, and then we can remove spark plugs fully. And they're all coming out very easily, which is good news. So we're going to have to remove the cylinder head cover now. Try and move that cable harness just out of the way gently, the one that goes to the coil packs. Just pop that towards the back. So we've got one clamp there that's holding that pipe, and that's a 10mm socket again. So if we remove the breather pipe first, plumbing pliers are quite useful for these sort of jobs. Got there in the end. Would have been easier had we just taken the top of the air filter off, I think. Might be wiser. So we've got 6 10mm cap nuts that we need to remove, and the one there, which is a bolt that holds the pipe in place, that bracket. So it's 7 in total. So that's the bracket off. And there's little rubber seals underneath the washers on these. You might need to lever the little washers up that are still in place there. There's the washer and the black seal underneath. Just remove all those, lever them up. Try not to damage them, just in case you need to reuse them. And now the cylinder head cover should come off with a little bit of gentle persuasion. You've got to watch the power steering pipe there on the left that runs across the top. Try and push that power steering pipe just out of the way, and there we are, there's the cylinder head cover. I'll add a shaded drawing now showing the main parts that you can now see from the top of the engine. There we are, timing chain there on the left. To establish that cylinder 1 is on the compression stroke, we need the top dead centre mark on the crank pulley lined up and the punch mark and arrow on the sprockets pointing up. The two lines also need to be aligned with each other. The lobes on the camshaft should be pointing away from the valves On a cold engine, the cam followers have some play in them as the valves would be closed, being that they're on the compression stroke. Rotate the crank 360 degrees if the above isn't the case. With the cylinder head cover off, we need to now note the position of the lobes on the two camshafts on cylinder number 1. And as we can see, they're pointing away from the valves. This means cylinder 1 is on the compression stroke. If they weren't pointing away, we would need to rotate the crankshaft 360 degrees, 1 revolution. There are also timing marks on the exhaust and inlet sprockets. Number 1 is at the top dead centre and on the compression stroke when the punch mark on the exhaust and the arrow on the inlet sprockets are at the top, and the lines are at the 3 and 9 o'clock position. Here is a clearer view of the marks on the sprockets using a mirror that's placed opposite those sprockets. Here is an example of the slack that you might find in the cam followers on a cold engine and with the valves closed. Now to take a look at the Sealey VSE 2020 leak down tester, which is the one I will be using for this test. So here's the tester in a blown moulded plastic case. Comes with some reasonable instructions, which is good. So the main part is a twin gauge manifold which is connected to the air compressor. We then have the main tube that goes down to the spark plug, and this is a standard 14mm size for the spark plug. And then we have a 12mm adapter and a 10mm adapter. So that should cover most petrol engine cars. So on the manifold we get a quick release connector as such, and we obviously get a regulator to control the amount of air going in from the air compressor. And you have to add your own connector to the end of this. It doesn't come with one supplied. The supplied air pressure must be between 45 and 100 psi to the regulator. So that covers the basics of a leak down tester tool. Once the air supply is connected to a cylinder, we can listen for the sound of escaping air and hence the cause of the low cylinder pressure. The air may escape to adjacent cylinder, cooling system, exhaust, oil dipstick tube and throttle body. For this reason we also need to remove the top part of the air filter housing. So we'll remove the cap off the radiator so we can hear air coming through that, and then we'll take the top off the air filter, and that will give us access then to the pipe leading to the throttle body. So we should be able to hear air coming through there if it does. So it's 5 8mm bolts to remove the top of the air filter, not forgetting the Jubilee clip, which is a 10mm socket. So we can screw the test gauge hose into cylinder 1 now. Just pop that in. It only needs to be hand tight. Then set the pressure of your air compressor between 45 and 100 psi. Now that the air compressor is set to the right pressure, we can connect the main air supply to the manifold of the tool, and we now need to adjust the second gauge on the right and set it to 0. So we use the regulator there. It's a very fine control, and we need to get that round to about the 5 o'clock position, which is 0, and then it's set. We can now connect this air line to number 1 cylinder and see what our loss is. And looking at the gauge, we've got about a loss of 47%, which isn't particularly good. Okay, we can now disconnect the air supply to cylinder 1, and then we can remove the connector pipe and put that into cylinder number 3, because the firing order is 1342. Cylinder 1 has been tested and we have a result of 47%, which is classed as moderate leakage on our gauge. We test the rest in the order that they fire. This engine's firing order is 1342. Thus our next cylinder to test is cylinder 3. If we turn the crank exactly 180 degrees, cylinder 3 should then be at top dead centre on the compression stroke. So I'm going to use a angle gauge on the crankshaft pulley so that I can see when I've turned it 180 degrees. So there we come, 180 and stop. So cylinder 3 should now be at top dead centre on the compression stroke. And we can double check that by looking at the cam lobes and making sure they point away from the valves. So we can now put the leakage detector hose into cylinder number 3. Again, just hand tight. I'm just going to check the cam followers again with my finger just to see if they're loose. And yes, they are loose, so that means the valves are closed. So we need to set the gauge to 0 using the regulator. Nearly there, and we're at 0 now. So we can connect that now to cylinder number 3 and see what leakage we've got. Quite a bit. It's looking about 60% there. So listening around to try and hear where the air's coming from. Sometimes you can smell petrol fumes coming through the cooling system because the air pushes it out. It seems to be coming through the cooling system from what I can hear. Certainly quite a bit of leakage. Yeah, about 62% there. Definitely hear it rushing out. Okay, release the air pressure and then we'll be going on to cylinder 4. Cylinder 3 seems to be leaking quite badly, with a vapor 62%, which is classed again as moderate leakage. Listening carefully, it sounds like it's entering the cooling system, so on to cylinder 4 now. Again, we turn the crank exactly 180 degrees. The arrow on the timing case and the crank pulley should be aligned again for cylinder 4, which should be at top dead centre on the compression stroke. So we need to turn the crankshaft pulley another 180 degrees so that we can do the test on cylinder number 4. So the pulley, the mark on the pulley at top dead centre will be back in alignment with the arrow on the casting of the timing chain housing. I will add a picture at the end just to confirm. Here's the view from the top of the engine of the marks. So I'm just going to check the cam followers on cylinder 4. Yeah. And there's a gap there, so I know that the valves are definitely closed. So we can then put the pipe into cylinder 4. So we can connect our air supply now from the air compressor. And the same procedure as before. where we need to zero the gauge on the right hand side to 0. And there we are, all the way around into the yellow section. And now we can connect to cylinder 4. This one's not as bad as the others by the look of it. It's about 40% leakage, just in this green. Listening again for where the air's coming out. Doesn't seem to be leaking as much. It's a lot quieter. Okay, so we've got our figure on that one. Take the air back down and disconnect. So we've just got cylinder 2 to do now. Cylinder 4 seems the best so far, at only 40% loss. I say only. That's rated as borderline low to moderate. Only cylinder 2 to check now, so another half turn of the crank for our 180 degree rotation. So another 180 degrees for number 2, and if we watch the cam lobes on cylinder number 2, you can see they're now pointing away from the valves, which is what we want. So I'll just check the cam followers again, and they're both loose. So we can screw in the adapter pipe. Okay, connect our air supply and set our right hand gauge to 0 again. This should be the last time now. Had to do that again because I overshot slightly. Like I say, very sensitive. Okay, and we can definitely hear that leaking. It says only 54%, but you can definitely hear that leaking. So it seems to be coming from the radiator. So I'm going to hold my finger over the radiator and see if any pressure builds up. That scared me. A lot of pressure. Do that again. So it's definitely coming into the cooling system. I can feel it building up. Yeah, so that's why the radiator blew. The pressure must have been really high in the radiator. I'll do it again. Alright, so we know that the head's going to have to come off. Yeah, you can see the water droplets misting out as well. Okay, so we've got a conclusion there. We've got to remove the cylinder head. So cylinder 2 seems to be where most of the trouble is at. It's giving us a 54% leakage rating, but the air is clearly entering the cooling system, which is clearly evident when I put my finger over the radiator cap filler neck. Pressure is building up in the cooling system, which would explain why the previous owner said the radiator blew. So we can conclude it's a blown head gasket and that we would need to remove the cylinder head. Thank you for watching and hope you found this helpful.